Hi everybody, and in this video I want to take you through an application type problem that uses the concept of rates and rational expressions. So the problem is right here. It says that the Turtle Dove Company, or the Turtle Dove Chocolate Factory, has two chocolate making machines, okay? And it says that machine A takes S minutes to fill a case with chocolates, and machine B takes S plus 10 minutes to fill a case with chocolates. So machine B obviously is a little slower than machine A. Working together, the two machines take 15 minutes to fill a case. And then what we're trying to answer is approximately how long does each machine take to fill a case working on its own. Okay. Now, the nice thing about this question is they've already defined the variable for us. S represents the time it takes for machine A to fill a case with chocolates working on its own. Okay. But here's what we know, that if the two machines work together, they take 15 minutes to fill a case. Okay, so it takes quite a while if they're working together to fill a case. But what we're interested when we solve a problem like this, because we're worried, we don't want to get into direct proportions, right? Because if we talk about direct proportions when trying to solve a problem like this, then what happens is when you add more machines, it takes longer. And that's not what we want to happen. If you add more machines, if you get more people working or more machines working, the time should go down. So we're dealing with rational functions, which is kind of a form of what we call inverse proportions, but the real word we want to use here is rates. When you increase the amount of work being done, you increase the rate. But let's talk about what the rate is here. So if two machines work together, the time it takes is 15 minutes, but the rate that they will work per minute will be, they will fill 1/15 of a case per minute, okay? Because if you take 1 minute and you divide it by 15, right, which is the total time, what you find is they fill 1/15 of a case per minute. Now, if you said, well, how much they fill in 2 minutes, that would be 2/15, and 3 minutes would be 3/15, and 4 minutes would be 4/15. But oftentimes when we do math problems, what we're interested in is a rate per one. It's called a unit rate, right? So it's like when you talk about your speed on the highway or something, it's kilometers per 1 hour. Well, in this case, we're talking about the fraction of a case filled per 1 minute, and so it's 1 minute divided by the total number of minutes that it would take to fill the case, and that's 15. So it's filling the case at a rate of 1/15 of a case per minute. Okay, so it's in 1 minute. What you're doing is you're completing 1/15 of the job. Okay, because the total amount of time taken to fill the case is 15 minutes. And what you're interested in is if you take 1 minute and you divide it by the 15, right? That tells you that in 1 minute, what you're getting is you're getting 1/15 of the case full. Okay. And like I said, if that concept sounds difficult, don't worry, it is kind of difficult. But another way, if the logic is confusing you, then what you can also say is, well, okay, well, what fraction would I complete in 2 minutes if it took me 15 minutes to fill the entire case? Well, then you take 2 and you divide it by 15th, and in 2 minutes you'd have 2/15 of the case full. So in essence, right, it's like a rate, but you can also think of this number as the fraction of the box that is filled per minute. Similarly, if you talked about like, well, okay, after 3 minutes, what fraction would be filled? Well, it would be 3/15 of the box, right? So, the fraction is kind of like the rate. The fraction filled is like the rate. And so that's, if you're feeling like a little bit weary or confused about how it's working, just think of it as the fraction of the box that's filled per minute. Okay, and it's 1/15. All right, so hopefully that clears that up a little bit now. But when the machines are working individually, what we say is, well, machine A takes S minutes. to fill the box on its own. So the fraction of a box or a case, as it were, that machine A could fill in 1 minute would be 1 over S, the total amount of time it would take machine A to fill a case. So in other words, if machine A, let's just make it up, took 40 minutes to fill a case, then in 1 minute, it would fill 1/40th of a case. And in 2 minutes, it would fill 2/40ths of a case, etc. Thing is, we don't know the total time at this point that it takes machine A to fill a case on its own. So all we can say is in a minute, it fills a fraction equivalent to 1 over S of a case. And machine B, we also don't know, but we do know that machine B is 1 over S plus 10 of a case. So 1 over S plus 10, that's the fraction that machine B fills of a case per minute, right? When you combine the two fractions of a case per minute that the two machines make, they add up to a total of 1/15th of a case per minute. Okay. So with that being said, we now can go ahead and solve this equation. But what we need is a rational common denominator. And so what we'll do is we will do the following. We will realize that we're going to combine things together, and the common denominator in this case can be figured out in a couple of ways, but maybe a better way to do this is just to combine these two together and set them equal to 1/15. So that's what we'll do. And I can do that pretty easily just by going like this. I can just cross multiply them, and I can say S plus 10 times 1, okay, plus S times 1, which is S, all over my common denominator of S times S plus 10 is equal to 1/15. All right, and now I'm going to try to solve this. So what I'll do is I'll combine some like terms together, and what I'll end up with is 2S plus 10 over S times S plus 10 is equal to 1/15. And then what I'm going to do is I'm going to multiply both the left side, and I'll just highlight it, and the right side by S over S plus 10. So on the left side, it's going to just cancel out. And what I'm going to be left with now on the right side is as follows. I'm going to have, on the left, I'll have 2S plus 10 equals 1 over 15 times S plus 10, okay? And I'm going to solve this. So I'll multiply the 1/15 by the S, and I'll end up with the following. 2S plus 10 equals 1/15 S squared, right, plus 10 over 15S. Okay, and now we're going to try and solve this. So we'll bring everything over to one side, and what we'll do is we'll say we've got the following. We have 0 is equal to 1/15 S squared. Okay, and then now we're going to have 10 over 15 minus 2S, so 10 over 15, okay, minus 2. So that's going to give us negative 4/3 S, negative 4/3 S. That's a 3, sorry about that. Okay, so negative 4/3 S minus 10. Right? And now we're going to solve that quadratic equation. So we're just going to plug it into our calculator, and we'll go ahead and okay, so we're going ahead and we're just saying mode, and we're going into a quadratic equation, and it's degree 2, and our A value is 1/15, and our B value is negative 4/3. And our C value is negative 10. And what we find is S either equals 25.8 or S equals negative 5.81. So I got two possible answers, S equals 25.8 or S equals 5.81. Now, I don't know about you, that's a negative 5.81, but a machine that could finish filling a case in negative amount of time would be quite handy, but that's impossible. So that answer is NA. And now we have our answer. That machine A, therefore, would take 25.8 minutes to fill a case on its own, and machine B would take 35.8 minutes, because remember, machine B is S plus 10, okay, which is 35.8. Okay, so your concluding statement, which I won't write out right now because we're running short on video time, but would be, therefore, machine A would take 25.8 minutes and machine B would take 35.8 minutes. Working together, they only take 15 minutes. Thanks for watching, and I hope you found that helpful.